Anthropic just accidentally leaked their entire playbook, 512,000 lines of code, 1900 files. Everyone's talking about what was inside, but nobody's actually explaining how it works. So I went through all of it, and I found 7 secrets that'll change how you think about every AI coding tool you use. Here's the thing most people get wrong. They think Claude Code is just Claude, but in your terminal, a chatbot that reads your files. That's not even close. What the leaked code reveals is a full system. 6 major components all working together. The AI model, that's just one piece. The other 512,000 lines are the machine built around it. Before we get into the secrets, let me show you the full picture first. So when we zoom into each piece, you'll know exactly where it fits. And one of these secrets involves a bug that was burning 250,000 API calls per day. The last one, something Anthropic built in complete secrecy that nobody was supposed to see. Here's what 512,000 lines of code actually looks like when you zoom out. 6 components, all working together. 1. The engine. They call it the query engine, 46,000 lines of code. It's the traffic controller. Every single message you type gets routed through it first. It decides, does Claude have enough to answer right now? Or does it need to read files, run a test, search the web? Nothing reaches Claude without going through this first. 2. Tools. Claude by itself can only think and write text. Completely helpless without these. The leaked code shows over 40 of them. Read files, run terminal commands, edit code, search your codebase, browse the web. The tools are its hands in the real world. 3. The cache. Every API call to Claude costs money. Without this, you'd pay full price every single time the engine sends the same instructions. The cache makes sure that doesn't happen. Honestly, this might be the single most important design decision in the entire codebase. 4. Memory. How does Claude remember anything between messages? Between sessions? 3 completely separate layers, each with a different purpose. And buried inside the memory system is something even more surprising. A deliberate forgetting mechanism. More on that shortly. 5. Agents. Claude Code doesn't work alone. It can create copies of itself. Multiple AI brains running in parallel on different parts of your project. The leaked code shows 3 completely different ways it does this, and one of them genuinely surprised me. 6. Defenses. Anthropic knows their competitors are watching every API call, so they build traps directly into the code. Systems designed to break anyone who tries to copy how Claude Code works. 6 components, 1 system, and Anthropic claims this whole thing was built by Claude Code itself. Let's zoom in. Starting with the engine. Most people think when you type a message into Claude Code, Claude thinks about it and responds. 1 question, 1 answer. That's not what happens. When you send a message, Claude Code first assembles the context. Your claude.md file, conversation history, and any relevant memories. Then it calls Claude. But here's the thing. Claude usually doesn't answer you directly. Instead, it says, I need to do something first, and asks to use a tool. Read a file, run a command, search the codebase. The tool runs, the result feeds back into the conversation, and Claude gets called again, and again, and again. One message can trigger 50 or more API calls before you get a single response. So when you ask Claude Code to refactor a module, and it takes a few minutes, it's not thinking slowly. It reads through your files, figures out what needs to change, rewrites them, runs your tests, and if anything breaks, it fixes that too before it ever responds to you. If you see Claude Code going in the wrong direction mid-loop, just hit escape. You don't lose anything. The context is preserved. You can redirect it immediately. Now, if every message triggers 50 API calls, that sounds expensive, right? Here's where secret number 2 comes in. Anthropic's solution is simple but brilliant. They split every prompt into 2 halves. The top half contains claude.md, system prompt, and tool definitions, and they stay same in every call. So they cache it. You pay for it once. The bottom half contains the current message, latest tool results, and the conversation history. They change in every call, and you pay each time. Here's why this matters to you specifically. Your claude.md file lives in that cached top half. After the first call, it's basically free. Every session, every message, it shapes how Claude behaves, and it costs you almost nothing. That's why it's the highest leverage thing you can configure. But here's the real kicker. When Claude Code spawns a helper, a subagent, using what they call the fork model, it creates a byte identical copy of the parent's context. The cached system prompt is shared, reducing per agent cost, but total cost depends on separate work done by each agent. They even track 14 different things that could accidentally break this cache. There's a whole file called prompt cache break detection.tas dedicated to exactly that. And there's a flag called dangerous uncached system prompt section. A warning written directly in the code to their own engineers. Change this, and you break the cache for everyone. If you've ever had Claude Code seem to know your project perfectly in one session, and then seem totally blank in the next, this is why. Claude doesn't carry all its knowledge around. It uses three completely separate layers. Layer 1 is the index, a simple file called memory.md about 200 lines. It doesn't contain actual knowledge, just short pointers to where knowledge lives. This gets loaded into every single API call. Layer 2 is the actual knowledge. Things like, this project uses PostgreSQL, or the user prefers TypeScript strict mode. These only get pulled into context when they're relevant to what you're working on right now. Layer 3 is session transcripts, full logs of every past conversation, stored locally on your machine. These are massive. Claude never loads them into context. It only searches through them when it's looking for something specific. The context window has a limit. On most plans now, it's 1,000,000 tokens, which sounds like a lot, but fills up faster than you'd think in a long session with lots of file reads and tool calls. And when it's getting full, Claude has to start forgetting things. The question is, what? The leaked code shows 5 separate strategies. They all run automatically. You don't trigger them. But understanding them explains a lot about why Claude behaves the way it does. The first is what they call micro-compact. It just clears out old tool results. Things like, I read that file 20 minutes ago, the raw output isn't needed anymore. Gentle. Barely noticeable. The second is context collapse. It summarizes chunks of conversation into shorter versions. You lose some details, but the gist survives. The third saves the most important facts out of the conversation into files on disk. So the key stuff is preserved externally even if the conversation gets trimmed. The fourth is full compact, summarizing the entire conversation history. This is what happens when you run /compact manually. And the fifth is a last resort. It just drops the oldest messages entirely. Gone. Now, here's the bug. They found that 1,279 sessions had hit 50 or more consecutive compaction failures. The autocompact would fail, trigger again, fail again, trigger again, over and over, burning through 250,000 API calls per day globally, before anyone caught it. The fix was almost comically simple. After 3 failures in a row, stop trying. That's the actual line from the leaked code. 3 things most users never do. Run /compact proactively at about 50 to 70%. Don't wait for autocompact to make its own choices about what to forget. Tell it what matters. Use clear between unrelated tasks. If you switch from debugging an API to writing front-end CSS in the same session, all that API context is just noise. Clear it. There's a command called BTW. It lets you ask a quick side question that never enters your conversation history at all. But what about handling multiple things at once? This is where it gets genuinely interesting. Claude Code can create copies of itself. Multiple AI agents working at the same time on different parts of your project. But the leaked code shows it doesn't just have one way of doing this. It has 3 completely different models. First is called fork. It creates an exact clone of the parent agent. And because that clone shares the parent's cached context, it's nearly free to spin up. This one's ideal for quick parallel tasks like reading 10 files at the same time. The second is teammate, a separate agent running in its own terminal pane. And here's the part that genuinely surprised me. They don't communicate through the AI model at all. Agent A writes a message to a file on disk. Agent B reads that file. That's it. They're literally passing notes. No AI in the loop for the handoff, just files. And that's actually clever. No network overhead. No chance of one AI misunderstanding the other. Just data on disk. Faster, more reliable, easier to debug. The third is worktree. Each agent gets its own copy of the codebase on its own Git branch. Completely isolated. Can't interfere with the others. Best for risky experiments you might want to throw away. Here's the practical takeaway. If you're working on something big and Claude seems slow, you might be bottlenecking it into one thread. Just say, use subagents to investigate this. That simple prompt spins up a fork agent that explores in a separate context window and reports back a summary. Your main session stays clean. Now here's where this gets into spy movie territory, because Anthropic knows their competitors are watching, and they built in traps. Here's the threat. Competitors, especially companies like DeepSeek, can record every request and response from Claude Code's API, then use that data to train their own models. It's called distillation, essentially cloning the behavior without doing any of the underlying work. Anthropic knows this is happening, so they build defenses directly into the code. The first defense is what they call fake tools. When this flag is active, Claude Code injects decoy tool definitions into the system prompt. They look completely real, but they're fake. If a competitor trains on this data, their model learns tools that don't exist and behaviors that don't work. This trick is actually centuries old. Map makers used to put fictional towns on their maps. If a competitor's map had the same fake town, you knew they copied yours. Same idea, applied to AI. The second defense is hidden reasoning. Between tool calls, the server sends back only signed summaries of Claude's thinking, not the full chain of thought. Someone recording API traffic gets the answers and the tool calls. But the actual reasoning process, the most valuable part for training a competitor, hidden. 6 secrets down. But this last one, this changes everything about where AI coding tools are actually going. KAIROS, mentioned over 150 times in the leaked code, fully built, gated behind a feature flag. Here's what it is. An always-on background agent. It runs as a daemon, a process that stays alive on your machine. And every few minutes, it asks itself, anything worth doing right now? It has a 15-second blocking budget. Any action that would take longer gets deferred, so it won't interrupt what you're doing. And everything it does goes into an append-only audit log. Every action recorded. You can always see what it did and why. It can fix errors on its own, update files, respond to GitHub events. To be clear, it prepares changes for your review. It's not pushing code or publishing anything on its own. Now, here's the paradox. This brilliant architecture, KAIROS, the cache system, the 3-layer memory, multi-agent orchestration, it all lives in the same code base as a single function in a file called print.ts. 3,167 lines, 12 levels of nesting. A function so long it would take you 20 minutes just to scroll through it. It's both the most sophisticated AI system ever leaked and some of the messiest code you'll ever see. Both things are true at the same time. That's where we actually are with AI right now. Which secret surprised you the most? For me, it was the file-based mailbox. AI agents passing notes on disk like it's the 90s. Drop yours in the comments. If you got something out of this, a like genuinely helps. Don't forget to subscribe the channel. Thanks for watching, and I'll see you in the next one.